Welcome to IS 300 and today's discussion of Chapter 2, the Internet as a Platform. In today's discussion, we will talk about Internet technologies and web-enabled applications that we use every day. Hopefully, you will think about these applications a little differently when we finish this chapter. We'll also talk about web application servers, and we'll talk about an Internet of Services. The Internet was a collaboration between the government, the Department of Defense, and a university project that was developed in the late 1960s. The first Internet was called DARPANET. It evolved into the commercial Internet because of the development of the first graphical web browser in 1993 by Mosaic. The Internet and the protocols that we know and love, HTTP, the Hypertext Transfer Protocol, and HTML, the Hypertext Markup Language, are standards that have been defined by the World Wide Web Consortium, the W3C, developed by Tim Berners-Lee in 1990. In 1993, we had Mosaic. In 1994, we had Netscape, which followed Mosaic. In 1995, we had Microsoft's Internet Explorer, and we had a very famous antitrust lawsuit which Netscape filed against Microsoft, stating that Microsoft had a monopoly because their browser was bundled with Windows 95. Of course, Netscape did win that lawsuit. They won the battle, but they lost the war because Microsoft simply paid them off and continued deploying their Internet Explorer throughout every Windows 95 implementation all around the world. And Netscape kind of dissolved into a company that was non-existent today. Other browsers, such as Mozilla's Firefox and Google Chrome, which we use every day, of course, and Safari, have come onto the scene lately. Microsoft has evolved and uses now Microsoft Edge. But the concept of the browser, which was established in 1993, changed the way we do business forever. HTTP, Hypertext Transfer Protocol, in conjunction with HTML, Hypertext Markup Language, has allowed us to use forms. We use forms every time we log on. Web-enabled forms provide an interface to legacy systems, so you can use a form to get to an old system on a mainframe, for example. You can publish information that is on a legacy system and make it available through the web. You also have universal client applications, which the browser is considered as a universal client application, which eliminates the cumbersome task of propagating upgrades to single desktops because you can rely upon the browser that is universally available to all clients that have a connection to the Internet. Client-server systems basically had to be redone in order to support web-enabled functions. VAT clients, became obsolete. Most websites rely on a web server, which runs one or more processes that receives HTTP requests from clients, typically using web browsers. Here's an example. You have a browser that is running HTML. It might be running some Java. It uses the Hypertext Transfer Protocol to send that HTML and or XML across the Internet to a web server. The web server then sends it to a legacy application and or a database. And this can also include 3270 emulation, which is they basically thin clients that may be still connecting through emulation software. Web-enabled architectures typically will use a JavaScript. The proliferation of Java led to the birth of application servers, Apache servers, IIS, which is Microsoft's web server. Those servers have been widely used for sending and receiving data from a client to a server across the network. Application server architecture takes advantage of that three-tier architecture that we talked about in Chapter 1, where you have a client, you have the business logic, and you have the data layer. 3 layers: the client, the business, the data. This gives you the ability to load balance to handle larger workloads. It's much more efficient than the client-server model, and it gives a clear separation of user interface, the business logic. For purposes of maintainability, you can upgrade one layer without touching the others and vice versa. You also have server farms, which can then load balance, and if one server is busy, the next server can handle the load very easily. The World Wide Web Consortium, the W3C, defines a web service as interoperable machine-to-machine interaction over hypertext transfer protocol. Web services that we use all the time. We place orders. We go to Amazon, we place an order, we track our shipment, we pay for it, we use credit card validation, we can view our bank statements and make transfers. All of those are services that are made available across the web. Usually they are reusable services. Several protocols have been developed for managing and sharing over the web. There is SOAP, the Simple Object Access Protocol. And remember, we talked about objects are nouns. They are places, people, places, or things. Developed specifically for publishing web services. SOAP applications call web services that are published by other applications over the internet. Then you have a service-oriented architecture, which uses SOAP and XML, the extensible markup language, which is a self-defining markup language used very commonly along with HTML, in conjunction with HTML. Then you have the representational state transfer, also known as REST, which is the protocol for remote data access, typically used in cloud computing. You also have a registry, UDDI, the Universal Description, Discovery, and Integration Registry, which allows businesses to advertise and list the web services that they publish. For example, a calendar is an example of a reusable web service that might be published, or a checkout cart is something that would be used regularly by businesses. They don't have to, the whole idea here is that you don't have to reinvent the wheel and write code for a calendar object or a checkout cart. You can simply deploy those objects and those services that are already available. Here's an example. So you have the client up here that's running some sort of a browser, and they've got a script that is invoked because of an application that the client has deployed. You have XML being sent across the wire using the hypertext transfer protocol. Then you have a mashup or a group of services, proprietary XML services that can be made available. And those services are ultimately sent to the web using either SOAP or REST. So we know that the internet has evolved from a government research project, University and Department of Defense research project called DARPANET, which ultimately led to the internet. The internet allows connectivity and ubiquitous access to data worldwide, and that DARPANET ultimately became the internet. Commercial internet made possible because of Mosaic, which was the first graphical web browser, followed by Netscape, and then followed by Microsoft Internet Explorer. Now we've got Mozilla Firefox, we've got Google Chrome, we've got Safari. Connection to websites, to back-end databases, has changed the way we conduct business. We can get to those back-end databases through a graphical user interface and input our data, send and receive information across the internet in HTML and or XML format. The graphical user interface has forms that provide a tool for user input. The user input sent over the internet to a web server. The web server then processes that data. Maybe the web server connects to a database server in SQL, structured query language, web server talking in HTML, and somewhere there's a translation between those two, and a send and receive from the client to the server. Let me know if you have any questions.